The strength of acids and bases is measured on a scale called the pH scale. The letters pH stand for potential of hydrogen. Pure water, which is neutral, has a pH of 7. Acids have a pH of less than 7. Hydrochloric acid has a pH of around 3. Hydrochloric acid is a component of gastric acid, which is an acid that is produced naturally in the stomach to aid in digestion. Bases have a pH greater than 7. Bleach, which is used in many households to disinfect, has a pH of around 13. What is the pH of chemicals found in your home? This is Introduction to Acids and Bases. Today, you will use your basic knowledge of the pH scale to investigate the pH level of several solutions found around your home. Many products you use at home can be classified chemically as acids and bases. For this investigation, we will use a pH sensor and 6 various household chemicals that I put into these beakers. I've got about 50 milliliters of each one. Today we're going to use seltzer water, soapy water, tomato juice, glass cleaner, vinegar, and sports drink. And you're also going to want to have a rinse bottle with distilled water so you can clean your pH sensor after each use, and a towel to blot it dry with. All right, let's get started. First, I'm going to connect my pH sensor to the device and click on Sensor Data. You want to make sure that only pH is checked off here, and then choose the digits display. So now I can see the pH on my screen. I'm going to remove the probe from its storage solution and push the cap up so it's out of the way. And you want to thoroughly clean the glass bulb with distilled water before you get started. Okay. All right, so I placed 50 milliliters of each household chemical into these 6 beakers. If you're doing this at home, you could use clear cups. All right, so let's test each one. For each one, you want to record the identity of the chemical, the qualitative observations of the substance, and its pH in Table 1. Let's get started. Know you can pause the video when needed to record data if I move a little bit too quickly. All right, so I'm going to get my pH sensor and place it into seltzer water to start. And you want to give the pH sensor time to stabilize. That means to quit changing, to slow its rate of change. So I'm looking. It appears I'm still decreasing. Still decreasing. All right, it's starting to slow down a bit. And I think we're good to stop here at 4.04 for your pH of the seltzer. Remember, rinse it off in between. All right, next let's do the soapy water. Get my probe in there, click start. This time it's increasing. Okay, already starting to stabilize. I think it's okay to stop there. And 9.33 for soapy water. Give it a rinse. Now let's try this tomato juice. This one's stabilizing pretty quickly. Okay, 4.31 for tomato juice. 3 more to go. Let's try the glass cleaner next. Okay, 11.32 for the glass cleaner. Let's move to some vinegar. Big difference between these two. Vinegar, 2.21. And our last one is going to be the sports drink. Okay, and a 3.04 for the pH of the sports drink. All right, and you've collected data on all 6. Well, we have just tested the pH of 6 different household chemicals. Your challenge is now to identify which were acids and which were bases based on your data. Additionally, you should now be able to answer the questions on your lab sheet using the data you collected. I hope you were able to see some commonalities in your data.